Hello everyone, in this lecture we are going to see the how we can measure the value of low resistance that is below 1 ohm with the help of Kelvin double bridge. Okay, so this is the circuit diagram for the Kelvin double bridge. You can see here we have used this is our lead resistance small r that we need to ignore that resistance from the value of the unknown resistance. So our unknown resistance is capital R here. Okay, these are our known resistance PQRS, and we have considered two resistance small p and small q for ignoring this lead resistance from the final equations, and the final equations will be R is equal to, according to Wheatstone bridge, what will be the final equation? That will be R equal to P by Q multiplied by S. So by ignoring this by compensating the value of this lead resistance that is small r, and we have put at two resistance small p and small q to get the compensation of this lead resistance. Okay, the supply is the DC supply is E, and here we have considered for 5 points, that is small a, small b, small c, small d, small m and small n. Okay, so we need to consider one condition for ignoring the value of this lead resistance, as we have discussed in the last lecture. So what is that condition? That P by Q, that means capital P by capital Q, should be equal to small p by small q. Okay, so for calculation if we will find the calculation, first we will apply KVL in loop A M C D A, the loop A M C D A. So if we apply KVL in this loop, we will have the equation EAD. What is EAD? EAD is a voltage drop in this branch, as you can see from green color it can be shown here, and VG is the voltage across the galvanometer, and EAMC is the voltage drop across this branch, that is shown in by the green color, as you can see. Okay, so VG equal to EMC minus EAD if we will further solve this equation. But if we will consider the condition of balance, then VG will be equal to 0. In that case EAMC is equal to EAD. So we need to find out the value of EAMC or EAD. Okay, so what will be the value of EAD? If we will see in that circuit, the value of EAD will be P by P plus Q into EAB. And if you will solve the value, you will find out the value of EAB. EAB will be equal to R plus S plus P plus Q into R upon P plus Q plus R multiplied by I. If you will solve, and you will find the value of EAB equal to this. So by putting the value of EAB in this equation, we will get the value of EAD. Now second, from equation 1 we need to find out the value of EAMC. So what will be the value of EAMC? That will be EAM plus EMC. Okay, that will be EMC plus EAM. Okay, so what will be the value of EAMC? That will be EAM plus EMC. So EAMC will be equal to this. If you will solve, and you will find out the value of EAM and EMC, we will have the value of EAMC equal to this. So we will put the value of EAMC and EAD in the equation number 1. By putting those values, we will get R is equal to, capital R is equal to P by Q into S. Okay, so in that formula you can see that there is no lead resistance. What is the value of lead resistance? We have considered the value of lead resistance is small r. So that small r has been ignored or neglected, or it is not there in the final equation. Okay, so as you can see, the final equation is same as our this equation. So we have successfully neglected and compensated the effect of lead resistance, that is the small r. So that is all about the Kelvin double bridge, and it is very suitable for measuring the value of low resistance, that is below 1 ohm, approximately 0.0001 ohm to 1 ohm we can measure with the help of this circuit very accurately. Thank you.